Welcome to Deep Dive Defense, military and aerospace enthusiasts. Over here we give rare insights you won't hear elsewhere. Today we explore why Iran stands out as an unlikely candidate among world nations to develop its own sixth-generation fighter jet. In our previous video, we examined the factors that could motivate Iran to embark on such an ambitious program, despite its prolonged neglect of notable investments in its air power. In terms of fighter jet manufacturing, Iran is primarily known for focusing on the fully domestic production of an inexpensive third-generation fighter jet, the F-5E Tiger II, originally made by the U.S. company Northrop. Iran's decision to select the F-5E was strategic, marking its initial entry into the exclusive group of nations capable of developing and producing their own fighter aircraft, including engines. The Kausar fighter jet, essentially a modernized F-5E airframe, was enhanced with fourth-generation avionics, including a glass cockpit and a planar array pulse Doppler radar. This choice was driven by Iran's extensive familiarity with the aircraft and its sizable F-5E fleet. However, another critical factor often goes unmentioned: the remarkably low production and operational costs of the F-5E platform. Designed as a straightforward and affordable supersonic fighter for smaller U.S. allies, the F-5E's simplicity made it an ideal starting point for Iran. That said, the gap between the Kausar F-5E and a sixth-generation fighter spans 3 full technological generations. Despite this huge gap, several compelling reasons suggest that developing a sixth-generation fighter by the 2030s could be a realistic objective for Iran. A foundational factor lies in Iran's acquisition of the Russian-made Sukhoi 35 superflanker, reportedly accompanied by an agreement to grant Iran a production license. This arrangement could provide Iran with invaluable experience in assembling fourth-generation plus heavy fighter jets, building upon the expertise gained from the limited serial production of its own Kausar fighter. Even more significant are persistent reports indicating that Iran is working on developing a heavy turbofan engine based on the AL-31 family used in the Sukhoi 27 and Sukhoi 35. Although it remains unclear how Iran may have gained access to the AL-31 or AL-41 engines, the possibility that Russia directly was incentivized to share this critical technology cannot be ruled out. Mastering a high-end engine production is the most formidable challenge in fighter jet development. Iran's current in-production engine, the AUJ, derived from the F-5E's J-85 small turbojet, represents a limited capability, developed after years of experience in manufacturing miniature turbojet engines for cruise missiles and drones. Iran's next leap involved reverse engineering a small turbofan engine from the US FJ-33, culminating in the Jahesh project. The potential provision of the full design documentation of the AL-31 or AL-41 engines by Russia would mean achieving a monumental step forward. Iran successfully reverse-engineered the US FJ-33 turbofan, but reverse engineering the AL-31 platform would be significantly more difficult due to its mechanical complexity. Of greatest significance is Iran's well-established gas turbine industry, which ranks among the few globally capable of producing a wide range of turbines on an industrial scale. This rare industrial capability uniquely positions it to swiftly initiate local engine production with adequate technical and manufacturing support. From a materials and metallurgical perspective, Iran has demonstrated its ability to produce the most critical components, such as single-crystal superalloy turbine blades for the modern CFM56 engine. This so-called hot core technology forms the foundation of advanced engines, and interestingly, China's WS-10 and WS-15 are also based on the CFM56. The critical importance of this primarily metallurgical capability is underscored by its historical inaccessibility. French President Pompidou failed to secure a technology transfer for it during extensive negotiations with US President Nixon in the 1970s. Consequently, Iran possesses the industrial foundation required to manufacture an engine like the AL-41F, a feat achieved by only a handful of nations worldwide. Successfully establishing local production of the AL-41F, with its thrust exceeding 14 tons, would eliminate the most significant bottlenecks in advancing towards a sixth-generation fighter jet. While airframe production and design present fewer obstacles than engines, Iran's experience with the Kausar and potential future Sukhoi 35 assembly would further prepare its industry. Additionally, Iran's infamous Quahair F-313 program, which has transitioned into an unmanned small fighter jet project, could contribute valuable manufacturing expertise in stealth and low observability airframe technology. Although the Quahair drone is reported to operate as a subsonic platform, its development has the potential to significantly contribute to a prospective sixth-generation fighter jet program by delivering crucial technologies and expertise in producing low-observable, stealth airframes. This includes the advancement of composite materials capable of withstanding the elevated temperatures associated with sustained supersonic flight, as well as the development of titanium structural elements for load-bearing applications in such aircraft. Furthermore, the Quahair, or an enhanced version of it, could function as a loyal wingman-type drone, complementing a sixth-generation fighter jet. Its production and refinement would, therefore, provide substantial support to the airframe aspect of a next-generation fighter jet project. The final asset supporting Iran's pursuit of a sixth-generation fighter jet program would be the capture of the U.S. RQ-170 drone in 2011. This feat granted Iran access to relatively advanced stealth technologies from which valuable lessons can be learned. It also included computer-supported fly-by-wire flight control systems, essential for managing the aerodynamically unstable flying wing configuration. Being able to utilize the vast effort the U.S. has put into such fly-by-wire systems to make them sufficiently reliable saves Iran valuable time if a tailless sixth-generation configuration is the goal. Additionally, the RQ-170's stealth and low observability features have provided Iran with critical insights into U.S. techniques and thinking used for enhancing penetration capabilities into contested airspace. Iran's used the RQ-170 to develop a whole family of drones and hence has vast experience with designing and producing such aircraft. Another essential key component enabling the development of a sixth-generation fighter jet is the sensor suite. This includes achieving comprehensive 270 to 360-degree sensor coverage through distributed active electronically steered array (AESA-type radars, along with electro-optical systems such as infrared search and track (IRST) sensors, and missile approach and warning system (MAWS). In both radar and optical technologies, Iran already possesses a foundation for further advancements. The 3rd Khordad and Bavar 373 air defense systems, for example, employ AESA X-band radar arrays in their engagement radars, and Iran is producing their transceiver modules in significant quantities to meet the requirements of these air defense systems. Adapting these AESA radar systems for airborne applications is an attractive option, as existing facilities for transceiver production could be utilized. This capability is particularly critical for a sixth-generation fighter jet, as multifunctional AESA arrays not only provide extensive radar coverage around the fighter, but also serve multiple roles. Beyond their primary function as radar, these arrays can act as high-powered data links and means for electronic warfare, enabling long-range, robust communication between fighter jets and their forward-deployed loyal wingman-type drones. In terms of infrared thermal imaging sensors, Iran has also made notable progress through its work on ground-based air defense systems. These advancements could be repurposed for airborne applications, allowing for the detection and tracking of aerial targets at ranges well exceeding 100 kilometers. While the United States' sixth-generation fighter program, known as the NGAD, has pursued an advanced adaptive propulsion system leveraging the experience gained with the F-135 heavy, large-diameter turbofan engine development, the Chinese J-36 program has chosen a different, lower-risk path. The NGAD is believed to utilize a variable cycle adaptive engine capable of altering its bypass ratio, allowing the design to rely on only 2 engines. In contrast, the Chinese J-36 employs a tri-engine layout, incorporating 2 WS-15 heavy turbofans on its outer flanks and a 3rd central engine. Although specific details about these engines remain unclear, the use of a DSI diverterless supersonic inlet for the central engine suggests it may be optimized for supersonic cruise. This could involve a modified WS-15 core without bypass duct, utilizing additional compressor stages to create a high-compression turbojet engine suited for high-altitude supersonic operation. A similar strategy could be adopted for a future Iranian sixth-generation fighter jet. By leveraging the very affordable Russian AL-41F engine design, Iran could justify a 3-engine configuration to achieve the high-altitude, long-range supersonic cruise capabilities required for speeds between Mach 2 and Mach 3. Such an approach balances technological ambition with risk mitigation to close on the performance benchmarks set by a cutting-edge design like the J-36. The clear goal for Iran would be to develop a fighter jet approaching 6th-generation standards, as only an aircraft of this superiority could provide the significant overmatch needed against U.S. 5th-generation platforms like the F-35 and F-22. Competing in the air power domain with a giant like the United States demands such a leap in capability. In terms of armament, Iran's existing air-to-air missile programs could support the development of this advanced fighter. Key examples include the Fakhur F-90B, a long-range beyond visual range air-to-air missile derived from the US AIM-54 Phoenix, and the Azarakh series of Sidewinder-based missiles equipped with imaging infrared seekers. These weapon systems could be further developed beside other subsystems like the production of heavy turbofan engines to be ready in the next decade. With these foundations, a 6th-generation fighter jet program aimed at fielding an operational platform by the 2030s may be in reach. The strategic importance of such a fighter jet project is not only in its technological edge, but also connected to its restricted accessibility. Nations producing 6th-generation aircraft are unlikely to export them in the foreseeable future, as doing so would undermine their export markets for their own 4th and 5th-generation fighters. This exclusivity emphasizes the monumental leap represented by 6th-generation platforms, particularly for nations like Iran, with specific high-end adversarial considerations. For Iran's Air Force, the development of a 6th-generation fighter jet would signify a transformation from a primarily defensive posture to an offensive preemptive posture. Against adversaries like the United States, Israel, and regional states aligned with the West, possessing such an advanced aircraft could be regarded as a future strategic necessity. If the AL-41 technology is transferred to Iran, its thrust vectoring capability could enable the development of a tailless blended-wing flying wing design similar to the J-36. However, radar signature reduction via the removal of the tail fins would not be Iran's primary goal. Instead, the priority would be improved aerodynamics of a flying wing, which enables a high supersonic speed, long-range hit-and-run fighter capable of dashing at around Mach 3 to strategic areas like the Mediterranean or deep into the Indian Ocean. Such an air power asset would allow Iran to disrupt and deter U.S. air operations by forcing them to abandon their mission objectives to engage in defensive countermaneuvers. A fighter jet with such reach and speed could shift Iran's air defense operations far beyond its borders, extending its power projection to regional theaters of conflict. The significant resources required to develop such an aircraft would be justified by it being a true area denial anti-access asset and challenge the numerical fighter jet superiority of its adversaries. So that's all for today. If you liked it, give a thumbs up, comment, and subscribe. It really makes a difference in the YouTube algorithm and is a great support to the channel. The real enthusiast can become members and given access to exciting membership area material. Thanks for your support and motivation. See you next time.